Hello everyone. Today we are going to move chapter 9 arrays. What is an array? An array is a contiguous memory locations that holds fixed number of data elements which are of the same data type. Or otherwise we can say an array is used to store a set of data elements in the computer memory. Simply, arrays are used to store multiple values in a single variable instead of declaring separate variables for each value. It is a special variable that can hold more than one value at a time. For example, you can create an array to store students' marks. So, we can store all the marks in an array under one name. Mark is the array name and array elements are 98, 44, 59, 60 and 30. Or car names. You can store different car names under one array name car. Audi, BMW, Maruti, Volvo, Nissan and Toyota. If you are not using an array, you have to declare 6 variables and assign each car name for each variable. So it is easy to use one array rather than 6 variables. So an array is a collection of data items. All of them are in the same type and can accessed using a common name. In the slide you can see an example. The integer type data values 23, 54, 32, 11, 16 and 44. And I have stored in an array. So a simple array is look like this, and this is storing in the computer memory in contiguous memory locations. An array can hold any type of data, but one array can hold only one type of data, homogeneous data. For example, an array can hold a collection of integers or a collection of doubles or otherwise a collection of characters like that. It cannot have integers and characters both in one array, half integers and half characters. We cannot store values like that. Only one type of data can store in a one array. A common name is used to address all the data elements stored in an array. You can give any name that you prefer for the array. Arrays are used to store a collection of data represent the same type. For example, an array named marks can use to store student marks, and car array can be used to store different car names like that. There are two basic types of arrays. One is one-dimensional arrays, or we can say single-dimensional arrays, and the other one is multi-dimensional arrays. One-dimensional array is like a list, and the most common one in the multi-dimensional arrays, two-dimensional array, is like a table. One-dimensional arrays are typically used in the occasions where we need to store linear data items. For example, a list of student marks, a list of phone numbers, number of pages in each chapter of a book, like that. First, we will look into the one-dimensional arrays. Later, we will discuss on two-dimensional arrays. Declaring arrays. Declaring an array is allocating memory for the array. In normal variables also, first we have to declare int value, char name, like that. In here, like same, first type of the array, it means data type, then array name, that any corresponding name that you like to give for the array, and inside of the square bracket, size of the array, then semicolon. In normal variables, only data type and name, but in here you have to give the square brackets for the size of the array. Then the first one is type. Type is data type of the elements which are going to store in the array. This can be any legal C language data type like int, float, double, char and etc. If you are going to store integer type variables in an array, you have to give the type as int. For the character array, you have to give the type as char, like that. Then array name. Array name is the name of the array which is used to address the elements stored in the array. Variable naming conventions are applying for the array names also. You can refer the lecture 5 Fundamentals of C Programming. In there I have discussed about identifiers. The naming conventions common for identifiers such as variables, functions and etc. Those are applying in the here array names also. The names are case sensitive. The names can consist of letters and digits including upper and lowercase letters A to Z, digits 0 to 9 and underscore. The first character must be a letter, cannot have any embedded blanks. Keywords cannot be used as names. They cannot be start with a special character like that. You can refer that unit for naming conventions. Then array size. Array size is the number of memory locations allocated for the memory. This must be an integer constant greater than 0. The square bracket symbol is an operator in C and it is called as the subscripting array reference operator. Inside of the square bracket we have to give the size of the array. If we actually don't know what is the size of the array that we are going to declare, we can leave that as empty. But it must use this operator with or without values in the array declaration. And you can see an example for array declaration in the slide. Declare an array of 10 elements named test marks of type double. So first data type of the array double, then array name test mark, then inside of the square brackets 10 the array size. So we can store 10 elements of double type values in here. So in here you can see few more examples for array declarations. First one is double salary 10. You can store 10 double type values inside of the array salary. Then the second one is char characters 26. You can store 26 character type values inside of the array characters. And the third one is float temperature 50. You can store 50 float type values inside of the array temperature. And the last one is int age 25. You can store 25 integer type values inside of the array name as age. In C, after declaring an array, a memory space will be allocated for the array. But these memory spaces are not cleared from their previous values. Memory locations may contain their previous values also. That can be stored any other values before by us, or sometimes it can be empty. Anyway, after declaring an array, we need to initialize array with the values that we are going to store. Initializing arrays. Initializing is assigning values for each memory location in the array. The normal variables we can initialize like value equal 10, or if we didn't declare it before, we can declare and initialize together as int value equal 10. So that 10 will store in the variable value. Here also the same. We can initialize array elements one by one or all the elements at once. First, we will look how the values can be assigned to all the array elements at once. You can see an example in the slide. Double balance 5. So the data type of the array is double and the array name is balance. Then inside of the square brackets 5. So we can store 5 values for this array. So equal, inside of the curly braces we have to give the values 1000.2, 2.0, 3.4, 7.6, 50.0. So we can store 5 double variables inside of the array balance. The number of values between curly braces cannot be larger than the array size. Array size is the number of elements in the array. Now individual assigning for each element. You can see the same array that we have used in the previous slide also. First I have declared the array double balance 5. So we can store 5 double type values inside of the balance array. Then 1000.2 I have stored in the 0th position of the array. Then 2.0 in the first position, 3.4 in the second position, 7.6 in the third position, and 50.0 in the fourth position. We can store 5 values inside of the balance array. Here the array is indexes. I will explain it in the next slide. Indexes are starting with 0 and continue to n minus 1. That n means the array size. Both having the same array, the previous slide and this one. Multiple assigning is easier than this assigning, because here we have to give one by one input, but in one line we can declare and initialize both. So in here you can see the array representation of the array balance that we have discussed in the previous couple of slides. How these elements are storing in the memory. The first element 1000.2 will assign to 0th position of the array. Then the second element 2.0 in the first position in the array, 3.4 in the second position, 7.6 in the third position, and the last element, the fifth element 50.0 in the fourth position. These 0, 1, 2, 3, 4 are called as indexes. Each element in the array has an index. This is a relative address of a memory location in an array. This is not the memory address, just a relative address that the location of an item in the array. In C, array indexes are starting from 0, not 1. If we omit the size of the array in our initialization statement, then it will be created as big enough to hold the number of elements that we are going to assign. In the slide you can see the same example that we have discussed earlier. Double, the array name is balance, but inside of the square brackets I didn't give any array size. But in the initialization I have given 5 values. So it is automatically adjust for the 5 elements. If we give 10 elements in the initialization, it will adjust for the 10 elements. Like that, if we give empty square brackets in here, it will automatically adjust for the number of values. Accessing array elements. Each memory location in an array can be addressed using the index. Using the index of each array element, we can assign a single value to an array element. For example, if we give balance inside of the square brackets 2 equal 3.4, then the double value 3.4 will assign to the second position of the balance array. Using the index, we can access the array element. So in here you can see example again. Printf, then percentage mark f for print the float point value, then comma balance 2. So it will print the value in the second position in the balance array. The index number contained within square brackets is called as subscript. So in here 2 is the subscript. In here you can see another example. Marks 3 equal 85. So we have to store the value 85 in the third position of marks array. In here you can see the marks array. It has 1, 2, 3, 4, 5 slots starting from index 0, 0, 1, 2, 3, 4. In here 85 we have to store in the third position, the index 3. So in here we can store 85. In the right side of this representation you can see the actual memory addresses of these slots. These indexes are only relative addresses. We can assign values to each array element one by one using a loop. Earlier I told how to give one by one elements to an array. In here using loops we can easily give the values to the array. In here The following for loop will assign values 0 to 4 to the array elements one at a time. So in here you can see hash include stdio.h, the library function. Then inside of the main function I have declared a array int array 5. Here I gave the array name, so array name also is array. For int I equals 0, I is less than 5, I plus plus. So the array element have to assign I for the ith index. We will trace this code and understand. In first I is equal 0, I is less than, so 0 is less than 5. Then array 0 equals 0. So in the array 0th position it will store the 0 value. Then 0 plus plus, then 1. 1 is less than 5. So again array 1 equal 1. So 1 will be stored in the position 1. Then 1 plus 1 2. 2 is also less than 5. So array 2 equal 2. Then 2 will assign to second position. Then 2 plus 1 3. 3 also less than 5. So third position it will store 3. Then 3 plus 1 4. 4 is less than 5. Then fourth position it will store 4. Then 4 plus 1 5. 5 is not less than 5. So it will exit the loop. So it will assign 0 to 4 according to the index of the array. So in here you can see a complete example. Take 5 integer inputs from the user one at a time and store all the inputs in an array and then print the output. So in here this is the code for that. First include the library functions, then inside of the main method first I have declared the array. The name of the array is array and it is an integer type array. It has 5 slots. Then a variable int counter equals 0. Then I have used while loop for getting the input from the user and for loop for print the array. So in the while loop it will iterate until count variable is less than 5. So it will give the message to the user that enter a number, and when the user enter a number it will get the input and array counter it will get the number that user gave. Then counter will be updated by 1. Then after that this is for just give the message the array is. Then using the for loop we can print the array. So we will trace this and get the output. First counter equals 0. 0 is less than 5. So it will print enter a number. Then we can give a number. Then it will get the number into the array and store it into the 0th position. Then counter plus plus, again this will be 1, like that until 5 values it will get, because here the array size is 5. So we can get 5 values for the array. After that there is one printf statement for print the array. Then for loop. It will loop 0 to 5 to print the array. So in here first I is equal 0. So 0 is less than 5. It will print 0th position value. So first we gave 45. It will print 45 because 0th position is 45. Then it will updated by 1. Then the first position it will print 36 because secondly we have given 36. Like that 89, 105. You can print the array using the for loop. Processing an array. After initializing an array, we have to perform certain activities on the stored data elements. For example, print all the elements in the array, like I discussed in the previous slide. Sort array elements in ascending order or descending order, take the average of all the stored elements, and etc. In C language, we cannot perform one single operation on all the array elements at once. The operations on an array should be carried out on element by element basis. To process array elements one by one iteratively, we can use loops. In the each pass of the loop, we can process one element in the array. For example, if we want to print all the elements in the array, we can use a loop. In the each pass, it means each iteration of the loop, we can read each element in the array by its index and print the array element. I have discussed that in the last example, how to print the array using a for loop. And if we want to add all the elements in an array together, in the each pass of the loop, we can read each element and add. So we will see some examples for understand this. So here is an example for print the array elements using a while loop. Earlier we print the array using for loop. In here, inside of the main method, I have declared and initialized an array. The array name is array, int array 5, and the elements are 1, 2, 3, 4, 5. And again I have declared a variable int counter equals 0. So while count is less than 5, it have to print the array. Here percentage mark d for indicating the integer type variable value. So in here array counter, it means here we can get the index. We will trace the code and understand. First, int array 5 equal 1, 2, 3, 4, 5. So array contains these values. Then count equals 0. 0 is less than 5. So it will print array 0, 0th index. So 0th index is 1. So it will print 1. Then counter plus plus. 0 plus 1, 1. Again go to the loop. 1 is less than 5. So it will print array 1, the first position. Then 2. It will print the 2. And again go to this. 1 plus 1, 2. 2 is less than 5. So it will print array 2, the second position. Second position is 3. So it will print 3. And 2 plus 1, 3. 3 is less than 5. So it will print array 3. So 4. And again go to this. 3 plus 1, 4. 4 is less than 5. So the last index array 4 will print the 5. After that 4 plus 1, 5. 5 is not less than 5. So it will terminate the loop. So it will give the output as 1, 2, 3, 4, 5 as the array. This is an example for finding a largest number in an array. So in here I have declared an initializer array, int array. In here I didn't give the array size, equal the array elements 5, 40, 20, 32 and 26. This in here there are 5 elements, so this will automatically adjust to 5 elements. Then another variable int largest equals 0. We will trace this code and understand. This for loop for go through the each element in the array. So first I have declared another variable in here, int I equals 0. So 0 is less than 5. Then it will go to the inside of the for loop. So again in here there is a if condition. If array index is greater than the largest value, then the largest value will be the array index. So in here we first 0 is less than 5. So now I is 0, the array 0, the index is 0, the 0th value is 5. But in here I have initialized the largest variable as 0. So here 5 and here 0. 5 is greater than 0. So the largest value is the 0th index 5. So again it will go to the for loop. So now 0 plus 1 1. 1 is again less than 5. Now the array I, the first position. So 40. 40 is greater than, now the largest value is 5, because in here we have assigned the 5 to the largest. So the 5 here, the 40 is greater than 5. So now the largest value is 40, because in here now 40. Then again go to the for loop. In here 1 plus 1 2. 2 is less than 5. So the second element 20. Now the largest one is, early largest one is 40. 20 is not greater than 40, so it will not go to the this condition, it will go to the again for loop. So 3, the I is 3, 3 is less than 5. So the third element is 32. Now still the largest value is 40. 32 is not greater than 40. Again it will not go to this because the condition is false. Again go to for loop. Now I is 4. 4 is less than 5. Then in here array 4. 4 is 26. 26 is not greater than 40. So it will not go to the this statement because the condition is false. So the largest value is 40 as I traced. So printf largest number is 40. If you hard to understand this, just trace it. Then you can understand how this works. Next, multidimensional arrays. To store data which has multiple dimensionalities, we are using multidimensional arrays, like data items organized as rows and columns, or a coordinate in a Cartesian graph is associated with x and y value. To represent such a coordinate, we have to use two values, so multidimensional arrays. To represent such values, we are using multidimensional arrays. Declaring multidimensional arrays. Declaring multidimensional array is similar to declaring single dimensional arrays, but we have to use separate square bracket for each subscript. Two-dimensional array requires two pairs of square brackets, three-dimensional array requires three pairs of square brackets, and so on. So the syntax is to declare a multidimensional array is type, the data type of the array, and the array name, like single dimensional arrays, then the square brackets according to the dimension. So in here you can see some examples for declaring multidimensional arrays. The first one is float table 50-50. So the type of the array is float, then the array name is table, and 50-50, 50 rows and 50 columns. For altogether 50 by 50, 2500 data we can store in the array table. And the second one is double records 100, 66 and 255. So we can store the values 100 by 66 by 255 values in the array records, but the values must be double values. And the last one is char page 2480. So the type of the array is char, array name is page, and we can store the values 24 by 80 values in the array page. Multidimensional arrays has multiple subscripts. Two-dimensional arrays. 2D arrays are common use case of multidimensional arrays. Two-dimensional arrays can be used to represent data arranged in rows and columns, like tables, like chessboard, spreadsheet, Cartesian grid, seat arrangements in a lecture, like that. Declaring 2D arrays. The syntax is to declare 2D array is also same as the earlier. First type of the array and the array name. The only difference is we are using two subscripts in here. One is for number of rows and one is for number of columns. This is 2D array, so we have to use two square brackets in here. In here you can see an example for declaring integer type 2D array named ARR with 12 elements. So we can declare that one as int ARR 3 4. In here this is integer type array and the array name is ARR. It has 3 rows and 4 columns. In here you can see the representation of the array, row 0 and column 0. So the element in here, the index is ARR 0 0. So in here row 1, column 1, then the index of this element is ARR 1 1. Like that we can store 12 elements in here, 3 by 4, 12. Initializing 2D arrays. We can initialize all the elements at once or one element at a time. In one-dimensional arrays also, we use these methods to store values. By specifying bracketed values for each row, we can initialize all the values a multidimensional array at once. So in the slide, you can see an example. Int ARR, int is the integer type and the array name is ARR, then 3 rows and 4 columns. So in here we have to give the values inside of the curly braces. So this is the outer curly braces. Then inside of that, this is one row and this is another row and this is another row. Those are separated by commas. So the index for this row is 0. This is the first row and this is the second row. Inside of the row, inside of this inner curly braces, we can give columns separated by commas. So 0, 1, 2, 3 is the element. So this is the 0th column, this is first column, and this is for second column, and this is for third column. So the index of this value is 0 0, index for this one is 0 1, this one is 0 2, and this one is 0 4. Like that in here, for this element 8, index is 2 and 0 because this is the 0th column, first column, second column, third column. This is second row. So index of this is 2 0. And for this 7, index is first row, then 1, and this is the last column, third column. So 1 3. So in here you can see the array representation for the above example. So in here first element 0, it will be stored in row 0 and column 0, and second element 1, it will be stored in row 0 and column 1, like that until 11. The 11 is in row 2 and column 3. Here nested brackets are used to indicate each row. The nested brackets which indicate the row are optional. It means 2D arrays can initialize without nested brackets. So for that you can see an example in here. Int ARR 3 4. Here 3 is the leftmost subscript and 4 is the rightmost subscript, and there are no nested curly braces in here. The elements will be stored in the one curly brace. In this case, the rule is the rightmost subscript increases most rapidly and the leftmost subscript increases least rapidly. Thus, the elements of 2D array will assigned by rows. It means the elements will be stored in rows first and then columns. In here, we have given that 3 rows and 4 columns. So we can draw the table like this: array representation, 3 rows and 4 columns. So first it will start to fill by row. So 0 is in here, then 1, 2, 3, then the columns are finished, then it will go to the next row: 4, 5, 6, 7, then again next row: 8, 9, 10, 11. Like that we can initialize 2D array without using nested brackets. In here you can see few more examples for array representations. The first one is int value 3 4. It means integer type array. The array name is value and it has 3 rows and 4 columns. But in initializing you can see there are 3 rows, it is okay, but in each row only 3 elements. It means no 4 columns in here, all of this. Only 3 columns can fill: 0th column, first column and second column. So in here array representation 1, 2, 3 and space for the third column: 4, 5, 6, again space for the third column because there is no element in the element for the third column. Like that you can fill the array. In the second example, the same array declaration: int value 3 4, 3 rows and 4 columns. In here 3 rows are okay, but columns in here 1, 2, 3, 4, 5, 5 columns, 0 to 4th index. In here 1, 2, 3, 4, 5, here also 5 and here also 5, but we declare it as 4. So it will fill as 1, 2, 3, 4 and 5 will ignore because there is no 4th column in here. Then 6, 7, 8, 9, 10 will ignore and 11, 12, 13, 14, 15 will ignore because we have declared the columns as 4. By using looping structures, we can initialize 2D arrays. Loops will initialize multidimensional arrays one element at a time, like the one-dimensional arrays. We can create a nested looping structure for initializing a 2D array. Outer loop will iterate through rows and inner loop will iterate through columns in a row. So this is an example for that. First I have declared an array int array 3 rows and 4 columns. In here outer for loop for iterate through the rows and inner for loop for iterate through the columns. We will trace the code and understand the array representation. Tracing is the easiest way to understand a program. So in here first x is 0, 0 is less than 3, it will go to the inner loop. Y is 0, y is 0 is less than 4. So now it will go to the statement. Array index here x is 0, y is 0, then the element is also 0. So it will store in here 0th row and 0th column. Then it will go to the again to the loop. Then here y plus 1. 0 plus 1, 1. 1 is less than 4. So it will go to the statement. Now x is 0, y is 1 and the element also 1. So it will store in the 0th row, first column, element is 1. Again go to the loop, 1 plus 1 2, 2 is less than 4. Now y is 2 and x is 0. 0 2 index, element is 2. So it will store in here. Then again it will go to here, 2 plus 1 3, 3 is less than 4, 0 3 3. So it will store in here. After that again it will go to here, 3 plus 1 4, 4 is not less than 4. So it will go to the outer loop. Now x is 0, 0 plus 1 1, 1 is less than 3. So it will go to the inner loop. Y is 0 and 0 is less than 4. So in here statement, now x is 1 and y is 0, then the element is 0. Here 1 and 0, first row and 0th column. So value is 0. Then again go to here, 0 plus 1, 1 is less than 4. So 1 1 1. So in here the index, first row and first column, then the element is 1. Like that we can fill the 2D array. Processing 2D arrays. Multidimensional arrays are also processed one element at a time on element by element basis. To access elements in a 2D array, we can use nested loops. Outer loop will iterate through rows and inner loop will iterate through the columns in a row, like I explained in earlier example. This is an example for printing array elements in a 2D array. In here you can see, first I have declare and initialize 2D array. Int array 3 rows and 4 columns, 1 2 3 4. This is 0th row and first row, second row, and 4 columns for each. So outer loop for iterate through the rows and inner loop for iterate through the columns. We will trace this. First row is equal 0, 0 is less than 3. Then it will go to the inner loop. Column is 0, 0 is less than 4. So the index for the row is 0, column is 0. So it will print the position of 0 0. So in here 0 0 position, element is 1. So it will print the 1. Then again the column value is updated by adding 1. So in here now column value is 1, row value is 0 0 1, then 2 will print. Then again 1 plus 1 2, 2 is less than 4, 0 2, the element is 3, 3 will be print. Then 2 plus 1 3, 3 is less than 4, 0 3, the 4 will print. After that the value will be updated, 3 plus 1 4, 4 is not less than 4, so it will print, it will go to the outer loop statement, new line statement. So it will go to new row. Like that it will print the array. Now we will see some details about character arrays. Strings can be considered as one-dimensional character arrays terminated by a null character. In C, string constant is represented as a list of characters enclosed by double quotes. In here the slide you can see an example, char string 6. So the type of the array is char, character type array, and the array name is string, and it can hold 6 values. So in here I have given HELLO 5 characters. So it can store in here. And the last one is null character. So we have to declare the array as 6, not 5. To hold the null character at the end of the array, The size of the character array contained in the string is 1 more than the number of characters in the word hello. So the characters are 5. We are declaring this as 6 for indicate the null character. So in here this one is not correct because it has 5 characters in here. The array size also 5. It cannot include the null character at the end. So this is wrong. This must be 6. When assigning a string constant to a character array, we can omit the size specification. In here, like the earlier declaration, we can use this as empty square brackets. So this value will be assigned to the array string and this will be adjusted for the letters in the string. Character arrays also can be initialized using individual character constant in an initializing list. In here you can see I have given character by character by enclosed by the single quotes H, E, L, L and O. At last we have to give null character. So this will store in the array string. By using %s conversion specifier in printf function, we can print a character array. Using %s conversion specifier in scanf function, we can take use input as a string. Normally, the address operator is used to provide the variable's memory address into the scanf function. An array name is the address of the starting element of the array. Therefore, address operator is not using when we are referring an array in a scanf function. I have discussed these things in the scanf function also. For the array names, we are not using address operator. So in here you can see an example for use of the scanf and printf function with character array. In here I have declared a character array char string 20, then printf function enter your name. So it will output as enter your name and we can type any name. So when we have typed a name, it will get into the array using scanf function. Here %s4 get in the array and string is the array variable name. So it will get into the array. After that it will print hello and %s4 print the array string. So it will print hello John. Now we will see some details about string handling functions in C language. In C language, there are number of string handling functions are provided in string.h standard library to manipulate strings. These are few of those. First one is strcat s1, s2. We have to use two strings for that. Concatenates string s2 onto the end of the string s1. The second one is strcpy. Two strings we have to give s1 and s2. Copies the string s2 into the string s1. Then the third one is strcmp. s1 and s2, two variables, two strings we have to give. Returns 0 if s1 and s2 are the same. It means first string and second strings are same. It will return 0. It is less than 0 if s1 string is less than s2 string. If it is greater than 0 if s1 string is greater than s2 string. Then the last function is strlen. We have to give only one string there. It will return the length of the string s1. We will see some examples for this. First one is string concatenation. In here I have declared two arrays, character type arrays, string 1 and string 2. They can hold 20 elements in each. Then I am getting the input as string 1 and string 2 from the user. So it will give the enter the first string, then I have given hello, then it will give enter the second string, then I have given word. So in here strcat for string concatenation, then string 1 comma string 2. So hello world. So this will concatenate and print. So in here you can see hello world. It concatenate these two words. Then the second one is string copy. In here I am getting a string from the user, so it will print enter a string to copy. Then I have given the word as hello. So using the strcpy function, it will copy the string 1 value to string 2 value. So it will print at the last the copied string is hello. Here I print the string 2. So from this function string 1 has copied to the string 2. So this function is for string comparison. In here I am getting two strings from the user, first one and second one. In here I have given hello and the second one also hello. So using strcmp it will compare first string and the second string. So both are same, so it will return 0. And in here printf function I have given the conversion specifier as %d, because we are returning the value from integer value. In the second one hello with simple h and hello with capital H. So in here ASCII values for simple h is 104 and capital H is 72. So the ASCII value all other are same. So in here together ASCII value is greater than this ASCII value. So it will print 1, because when comparing string 1 is greater than string 2, so it will print 1. If we use capital H in here and simple h in here, so it will print -1, because string 2 is greater than string 1. So this function is to get the length of a string. In here I am getting a string from the user, enter a string, and I have given the string as hello. So using the strlen function it will calculate the length of the string 1 variable. So in here hello 1 2 3 4 5 characters in here, so it will return the length of the string is 5. These are few string handling functions. There are many more string handling functions in C language. To upper function. To convert a lowercase character into an uppercase character, we can use toUpper function. This function is declared in the ctype.h header file. So in here you can see I am giving the toUpper function with the character simple D. So it will output it as capital D, because this toUpper function is converting simple characters to capital characters. Then toLower function. To convert an uppercase character into a lowercase character, we can use toLower function. This function is also declared in the ctype.h header file. So in here you can see I have given toLower and capital letter in here, capital L. So it will convert it to the lower letter and output it as simple A. Okay, from this chapter you have got an idea about arrays, one-dimensional arrays, two-dimensional arrays, some more details about character arrays, and string handling functions in C language. The syllabus is almost over now. We have to do practical sessions for these things to get more clear idea about the theory. We will see, and I hope to conduct some quizzes and give some more tutorials to cover the theory parts that we have discussed so far. I will let you know through the CAL about these quizzes. Keep in touch with the CAL and go through the lectures again. I have uploaded the PDF version of the slides and a simple worksheet for this part. Find those and try to write the answers for the worksheet. And also use the reference books, and you can go through the previous lectures that connected with this lecture. And if you have any doubts or anything that you cannot understand, you can contact me through the email. I have given my email address as usual in the first slide. Thank you.